All right, Math 1, Unit 5B, Section 2, slope from a graph in 2 points. So, slope is normally called rise over run. Slope, we could call that rise over run as a fraction. And it talks about how much does the graph go up in relation to how far across does it go. So, another way to think about this would be rise would be the difference in y, right? Because the y-axis is the vertical axis. That's the up and down axis. So you can talk about difference in y over the difference in x. Okay, so those are some different ways to think about that. Some people also call slope rate of change. Right? Those are they mean the same thing in this context. So slope, our answers to all these problems are going to be some kind of fraction. It might be an integer, but normally a fraction. And another thing to think about is if you look at number 1 here, whenever I look at these problems, I look at what if we had a little car here driving along the line. The car drives from left to right, just like how we read. If the car is going downhill, then we're going to have a negative slope. If the car is going uphill, we're going to have a positive slope. So in number 1, we know that we should have a negative slope. And what we're going to do here to actually get our slope is we're going to count how far up or down, in this case down, does the line go to how far across. And we're going to use these 2 points that they've already labeled for us. So they've already put little dots on. So we're going to count how many units down do we go? 1, 2, 3, 4, 5, 6, 7. So our rise is -7 because we went down 7. And our run is going to be 1, 2, 3, +3 because we went right 3. So if we could, we would want to reduce that fraction, but -7/3 doesn't reduce, and that's our final answer, -7/3. So what we said that the rate of change, or the slope, of this line in number 1 is -7/3. That's how fast it's going down. All right, let's look at number 2. So number 2 is one of those weird ones. Whenever you have a vertical line, this is a special case scenario. A vertical line where there is no run, right? We could say, well, to get from the up here, we'd count down 1, 2, 3, 4, 5. So we went down -5 or down 5. And to run, well, it didn't go left to right, so it's 0. And you can't have a fraction with a denominator of 0, so this doesn't work. And it's actually undefined. Okay. So a vertical line, vertical line is undefined. Okay. So anytime you see a vertical line, you could just go ahead and say, well, that's going to be an undefined slope. All right, let's look at number 3. So we have rise over run. That's what we're trying to find. So I normally start on the left side of my graph, and I'm going to count over. 1, 2, 3. Oop, wait. Oh, normally I do my run first. I'm sorry. Or my rise first. We go down 1. I apologize. So -1 because we went down. And then 1, 2, 3 is our run, so 3. So -1/3. That's our slope. All right, number 4. Now something to notice about number 4. Number 4 is our first line that is going up, right? If we had our car here, that's a really good car, I know. And it's driving this way, it's having to go uphill. So we're going to have a positive slope. So let's look at our 2 lines here. We want to do rise over run. So let's take this point here and we'll rise 1, 2. We went up 2 spots. And then the run, we move right one spot. So 2 over 1. And 2 over 1 can reduce, or can simplify to just plain old 2. So our slope in this case is just a plain old 2. And it's positive because the line is going up. All right. Number 5 and 6, all of these talk about find the slope of the line through each pair of points. So we don't have a graph, we just have points. Now let's go back up to the top and we'll look back up at here and we'll find our notes, or our formula rather. Another way to talk about slope would be y2 minus y1 over x2 minus x1. And that would be a formula that you should probably write down. Slope, you want to write slope equals y2 minus y1 over x2 minus x1. And this is talking about if you had the point x1, y1, x2, y2. So what this formula means, whenever you have the top, the numerator there with y2 minus y1, it means how far apart are the y's. Another way of saying that is what is the difference in y? And the bottom says the same thing. How far apart are the x's? What is the difference in x? Okay, so it goes right along with those, the verbal way to say it. But this is our actual formula. So let's go back down to number 5, and I'm going to write my formula down just so that I have it. So slope equals y2 minus y1 over x2 minus x1. Now you might say, well, which one is x1 and which one's x2? And the answer is it doesn't matter, but you just have to pick one. So I normally do the first one is my x1. So here's my x1, here's y1, here's x2, here's y2. If you were to flip those and have the x2s and the x1s flopped, that would be okay. It doesn't matter which point has your 1s and which point has your 2s. It just matters that the 1s go together. So if I'm going to plug into the slope here, I'm going to say, well, y2, 14, minus y1, 9, over x2, which is, what is it, 16? Yeah, 16. 16 minus x1 is negative 8. So here, whenever we reduce this, we have 14 minus 9 is going to be 5. 16 minus negative 8 is really going to be a plus 8. So what is 16 plus 8? Is that going to be 24? Yeah, 24. 24. And now we ask ourselves, can we reduce that fraction? And the 5 we cannot reduce, so that's our answer. That is our slope. Right. So we could have plotted those 2 points and then done it like we did with numbers 1 through 4. But this way is just a little bit faster because we don't have to actually graph it. All right, let's do number 6. So again, I'm going to be using that formula. I'm going to label, this time I'm going to put my x1s in the second spot, just because. All right, so I have y2 minus y1, 17 minus 17 over negative 9 minus 1. Well, that gives me 17 minus 17 is 0, and negative 9 minus negative 1 is negative 10. Well, 0 divided by anything is 0. So our slope is 0. But what does that mean? Why is it 0? I want to sketch just a little graph here so that you can see what's happening. You don't have to sketch this, but I think it helps. So here's 17, and we've got a point here at positive 1 and a point over here at negative 9. So really here we have a horizontal line. Right? If you had your little car driving here, the car would be driving on level ground. It wouldn't be going uphill, it wouldn't be going downhill. It's going right in the middle, it's going at 0. So a horizontal line has a 0 slope. Okay, so we talked about, where was it? Vertical lines up here? Yeah, a vertical line has an undefined slope. A horizontal line has a zero slope, or a slope of 0. All right, let's look at the next ones. So again, I'm just going to write my slope formula down. Slope equals y2 minus y1 over x2 minus x1. All right, let's look at number 7. I'll say x1, y1, x2, y2. So y2 minus y1, 4 minus 14 over 14 minus 14. All right, so let's highlight where I grabbed these from. That 4 came from there. This 14 came from there. This 14 came from there. And this one came from there. There were so many 14s, I wanted to highlight that so that we could see where they came from. All right, so the numerator there is going to be a negative, or 4 minus 14 is negative 10, and 14 minus 14 is 0. So this again is undefined. And you might want to ask yourself, well, what does that mean about the line? What kind of line is this? Can we say anything special about the line that goes through those points? That line has to be a vertical line. Vertical. Right. And if you end up graphing that, that is what it is. So yeah, number 8. Let's keep that slope formula there. We'll do x2, well, let's make that x1. I like it more. x1, y1, x2, y2. So our formula now, we get y2 is negative 7 minus 12 over negative 15 minus negative 17. So negative 7 minus 12 is going to be negative 19. Negative 15 minus negative 17, well, really we've got 2 negatives there. That's a plus. So this is going to be a positive 2. So our slope here is negative 19 over 2. And that's it. The big thing for this lesson is to try to memorize this slope formula here. This guy, if you can memorize it, all these problems will go much faster for you.